All right, here quiz 5, solutions for Math 112. In this first problem, we're told that t is an angle in the second quadrant, and the sine of t is 2/3, and we're asked to find the secant of t. Let's see, I think the easiest way to go about this is kind of using the way we've been writing these in class, is that sine of t equals y, which is a little bit of a weird thing to write, but really what I mean is if we measure an angle t counterclockwise in standard position, then the point on the unit circle that we end up with, its y-coordinate, is what the sine of t is defined to be. So as long as you know what that means, it's not too weird of a statement. And what we're asked to do is figure out the secant of t. And so while we're here, I'll point out that the secant of t is 1 over x. So we're given that y equals 2/3, and we're asked essentially to find x, because if we could find x, then flip it upside down and you got 1 over x. So how are you going to figure out x if you know y? Well, turns out that we have this Pythagorean identity. I guess at this point it's the equation of the unit circle. It'll later turn into the Pythagorean identity that x squared plus y squared equals 1. So I know y equals 2/3. So I got x squared equals, you might even have these numbers memorized at this point. I think we've done this example a few times, but whatever. X squared plus 4/9 equals 1 if I take 2/3 and square it. So now I subtract 4/9 from both sides of the equation, and I get x squared is equal to 5/9. So from there I take the square root of both sides of the equation, and I get x equals plus or minus the square root of 5/9. But then I'll say, but because t is in quadrant 2 kind of up and to the left, if you're staring at your unit circle, I know the x coordinates are negative there. So really what that tells me is that my x coordinate is equal to the negative of the square root of 5 over 9, which can be rewritten as the square root of 5 divided by the square root of 9. The square root of 9 is just 3. So I got x equals negative square root of 5 over 3. And if I know that x equals negative square root of 5 over 3, then I got that the secant of t is 1 divided by that value. Well, a positive number divided by a negative number is going to be a negative number. And so I have something that looks like this. And really I should say find and simplify, because I don't want you to leave your answers looking like this. What I would prefer you do is say that when you're dividing, it's the same as multiplying by the reciprocal of the denominator. So instead of root 5 over 3, you can view it as 3 over root 5. So I got negative 3 over root 5, which is not rationalized. To rationalize, I multiply the top and the bottom by the square root of 5, and I get negative 3 root 5 over 5, which would serve as my final answer. Part 2, you do something pretty similar, so similar that maybe I shouldn't have asked you to do another one. But the challenge here is it's a little bit harder algebraically. The tangent, maybe you have memorized, as y over x. So I have y over x equals 2/3, and really what I'm trying to figure out is the sine of s. And the sine of s is the y coordinate. So I want to solve for y. I know that y over x equals 2/3, and I also know that x squared plus y squared equals 1. Well, let's see, if I want to solve for y, what I'd like to do is plug in x here. So I'm going to multiply both sides by x, and then multiply both sides by 3/2 to get that x is equal to 3/2 y. And the reason I'm going to do that is that will allow me to plug in here and get 3/2 y squared plus y squared equals 1. And now that I have this, all I got to do is solve for y. So 9/4 y squared plus 1 y squared equals 1. Well, 9/4 of these plus 1 more, aka 4/4 more, gives me 13/4 of these y squared things. So I got 13/4 of y squared equals 1. And now if I multiply both sides of the equation by 4/13, I get y squared is equal to 4/13. I then take the square root of both sides of the equation, and I get plus or minus the square root of 4 divided by the square root of 13. Square root of 4 is just 2. And then I say, wait a minute, I'm in the first quadrant because S is, that looks like all one word, because S is in quadrant 1, y is positive. So what I get is that y equals positive 2 divided by the square root of 13, which I should rationalize as 2 root 13, over 13, which would be the answer to my question. This is the y-coordinate, which is what the sine is defined to be. So that'd be the answer right there. All right, 3. 3, I don't know. Maybe it's the easiest one if you just know how to do it, but if you don't know how to do it, it's impossible. So I don't even know what I'm talking about. Let me just do the problem. So you got a right triangle, not necessarily drawn to scale here, but here's a right triangle. So this is 90 degrees, and it has legs of length 2 and 5. Well, this looks longer than this, so I'll call this 2 and this 5. And if this one's longer than this, that means this angle is shorter than this angle, or smaller, I guess. So this right here would be A. And so what I want to figure out is the sine of A, the cosine of A, the tangent of A, and the cosecant of A. To figure out the sine of A, this is a SOHCAHTOA. If that means anything to you, it tells you that the sine of angle A is the ratio of the length of the side opposite to the hypotenuse. Wait a minute, you didn't tell me the hypotenuse. True, but you can figure it out. All right, maybe I call this, I don't know, H for hypotenuse. I know that a squared plus b squared equals c squared. 2 squared plus 5 squared equals h squared. So 4 and 25, aka 29, equals h squared. And so h is equal to the square root of 29. Technically plus or minus the square root of 29, but because I am talking about side lengths here, I would just say that it's the square root of 29. So I got that h is equal to the square root of 29, and that'll be all that I need to answer these questions. Sine is opposite over hypotenuse, so it's 2 divided by the square root of 29, aka 2 root 29 over 29 if you rationalize. Cosine is adjacent over hypotenuse, so it's 5 divided by the square root of 29, which again, if you rationalize, is 5 root 29 over 29. Tangent is opposite over, well, okay, tangent you have options. Say tangent is sine over cosine, so it's this number over this number. You could do that. Might be easier to look at your picture and realize that tangent is opposite over adjacent. So relative to this angle, 2 is opposite, 5 is adjacent. So I get tangent is just 2/5. And then cosecant is 1 divided by sine. Maybe I'll even write that. And I know that sine is, well, you might be referring to this answer, but it'll make your life easier if you think about it as 2 divided by the square root of 29, because when you're taking the reciprocal of that, you get root 29 over 2, and now you don't need to rationalize. So for my answers, I want to make sure that I have simplified and rationalized forms. I guess you could argue those mean kind of the same thing. So I'll put a box around those guys, and I'll call this quiz good.